Hello everyone and welcome back to the introduction video of Animation Combo System. This is the first part of the two parts video that I'm planning to upload. In this video I'm going to explain the theory behind Animation Combo System and how it's supposed to work, how you can make use of it and so forth. So let's get started. So what does it offer? What does Animation Combo System offer? It's user-friendly, almost no learning curve except a few new terms. There are a few new language terms that you will need to understand to use the package correctly. The rest of the work is just a matter of dragging and dropping, so nothing special there. It has a fast workflow. It has a mag. It has a fast workflow. In just a few minutes, you will get up and running with the combo for your character. It's very modular and it maximizes usability. Creating animation attacks data once is the concept of the whole system. So all objects are of type scriptable objects, so you can create them once, you can move them around, you can duplicate them and do stuff with them. Um, so you can create the data once, and then you can simply create tens of variants and combinations with these data because they are physical data on disk and not serialized in the inspector. That helps the designer to create a sense of variety to the game. So, for example, using the same animations in different order for NPCs, or duplicating and reordering the animation for um, reordering the animation um, in a different order or in a different sequence and assigning it to a special in-game mechanic, for example, unlocking a new ability or something to the player. Um, One good thing about it's also it has zero dependencies with other libraries and even other Unity components, except the animation component, of course. But yeah, it's always nice to have zero dependencies with something, and everything is managed internally. I think that's a good thing. Um, it's flexible and extendable. That means, or what does that mean? What that means is that it triggers useful events, which the programmer working on the game can subscribe to them and add custom logic and extend the system if he wants to. This is very helpful for different kinds of scenario, uh, because creating, for example, head detection for a fighting fantasy game is different than creating a head detection for a game that's based on or tries to be realistic as possible. While, for example, a game where the player has to fight other people with sword. So yeah, it's always good to have this kind of layer of extendability and flexibility. And also one last thing, the full source code is included. That means you can always read the source code and make changes if you wished. So, how to create combo attacks? Now, first step is simply dragging and dropping the attacks animation in Mechanim. You open up the animator window or Mechanim and you drag and drop the animations inside them, and that's pretty much all. Second, you create you create attack objects on disk, and that's done by going to create and then attack object, and that's that. We're going through this in detail later on in the next video, where we're gonna have to recreate a demo scene from scratch. And now create a combo object also the same way and assign the attack object or objects to them. Assign the combo object in the combo sequencer class in the inspector and hit play. Here I have a simple graphic that demonstrates how is that actually or how to visualize this in your head. So you have the combo object, which is object on disk. You have the attack objects, which are also objects on disk, and you put these objects, the attacking objects, inside the combo objects, and the combo object inside the inspector of the player, and that's that. So here is an example attack. Um, don't worry too much about the parameters here. We're going to explain them all in detail again in the next video, but just to have a general look. First of all, the animation name, which is the name of the animation inside the mechanism window. That's very important to have the same. Link begin and link in transition duration. This is all linking options. I'm gonna go through them later on in this video because they are a little bit complicated to understand in just simple talk. But not too complicated, just a matter, it just has some folds in them. Now we have a very important field here called events. I have two types of events. I have damage events and I have generic events. Now, damage events is self-explanatory, I guess. When the animation itself seems like it's hitting something at a specific time on that animation, say at 60% of the animation's length, the sword of the player actually makes contact to the enemy. So I'm gonna set the first element. I can create as many damage events as I want to, but in this case I have one element. I can set the first element to 0.6, which means 60% of the animation's length. At this time period, exactly at this time period, I'm going to trigger a damage event, which the custom class of handling damage and checking for damage and all that stuff is gonna get notified and it's gonna kick off its logic. And I'm passing a 20 HP damage to the event, to the message itself. So the class knows that, yeah, I must apply 20. Oh, sorry, go back. So the the class knows that I have to implement 20 damage to the player. Now, in some cases, I might want to add generic events, for example, some audio effects or some particle effects or some other effects that I might be interested at. So I can create as many events as I want to. I can give it a name. The name does not matter, just something for the designer to see if it's happening. Trigger time, also the same thing with the damage event. It's the time at which I'm going to trigger the event. And then the key, this is very important. So the key is gonna be used inside the your custom class, which is going to implement these messages. Uh, the key is gonna be used to differentiate between which event is which. So it will look something like a switch statement, which says case effect, then do this, case audio effects, then do that, and stuff like that. And default, do nothing. Fighter screaming also the same thing, but with another key, audio effects. Right? So armed combo. This is an example of a combo, a combo object. Um, Now, the first option is a layer name. So as you see, your animations or your combos, I mean your attacks, do not all have to be on the same layer. They can be distributed across multiple layers in the mechanism. So in this case, I have a layer called full body, which houses all the animations that I want to. So I have to put the name of the layer in here. I can put as many animations as I want to, and that's the beauty of having scriptable objects. I can duplicate, I can reorder, I can do stuff, which gives me a new combo effortlessly, basically. The input sequencer is a juicy term itself. I mean, it's a juicy part itself. Um, it allows you to design your input on how to trigger this combo. More on that later on this video. Now let's speak about the combo sequencer itself, which is the thing that will be in the inspector. So in your class, and whatever class it is, it does not matter which class, you're gonna have to put this subclass, I guess, or another class in it in the inspector. So it's called combo sequencer. So you're gonna write public combo sequencer arm sequencer. I might have another one for an unarmed sequencer, which I'm gonna explain and use in the demo scene, where my player can do unarmed attacks and armed attacks. So yeah, in your script in your class, you just need to put this as public, so it shows in the inspector, and use the inspector to assign combos, and yeah, and that's that. So this is how it looks like. So I have my armed combo. I have a number of combos. I can put as many combos as I want to, and it requires a animator component. And you simply hit play and see it in action. So how to trigger the combo in game? For that, we use the input sequencer inside the combo object. And that's this part over here. So I have a type of the type of the input sequencer. I've got three types by default in there. I'm going to explain them one by one right now. I have an option called enable time limit, which is basically a time limit after which the sequencer will reset, the input sequencer specifically will reset its buffer, um, so that you can start new. In this case, after 2 seconds, the buffer will clear itself. It does not have to be enabled, you can disable it if you want to. I mean, it's just a matter of design. And then I can put as my actual input list here, or input sequence here. So, what are the input sequencer types? I have full, I have partial, and I have partial appending. So what does that mean? More on that later, but first of all, we need to explain the common traits between them. So the enable time limit, I explained that already. There's an important one. If the input sequence list is longer than the length of the attacks list, the sequencing type will set itself automatically to full. Oops. And if the attacks list is longer than the input sequence list in length, the last keystroke will chain the remaining attack animations together in one long sequence. Um, this table explains a little bit of the stuff surrounding the input sequencer. So, um, by the way, all the stuff are gonna be found in the documentation inside the package. Right? So the full sequencer, the player must input the full key sequence before triggering the combos and its animation. Um, an example of that, if you remember back in the day, the game GTA Grand Theft Auto, it had cheat codes, and you had to input the full cheat code before something happens. This is an analogy. If the animation combo system does not trigger cheat codes, but an analogy that you have to put in the full sequence before triggering the animations. All right. Um, Now, if you remember, I had this. Wait, where is it? Yeah. Oh no. No. Which one was it? Um. So if you remember, I had the linking options, link begin and link end. They have different functionality based on the type of the sequencer. So in the case of the full sequencer, the link begin function is the time at which we link transition to the next or we link or transition to the next animation in the combo chain. The link end does not have an effect. Partial sequencer. So the first keystroke triggers the first animation in the sequence. Onwards, every correct keystroke within the link begin and the link end time span of the animation triggers the next animation in the chain. Keystrokes that aren't within the time span are completely ignored. So you have time link begin and link end. If you time your input within these time period, then you will successfully move to the next chain to the next animation. Sorry. If you input anything outside this time span, then it will be ignored. And of course, if you input an incorrect keystroke within the time period, it will ignore us. I mean, it will break the sequence, of course, right? An example of this would be games like, I guess, Assassin's Creed and God of War, for example, where the designers of the game have set the link begin and the link end in such a way that the animation looks like it's ready to transition to another animation. So they have two animations, and at a specific time period of the first animation, there is a pose of the player where the player looks like it's ready to transition. The player instinctively knows this and presses the correct key sequence and therefore triggering the next animation. If you don't put anything or leave the joystick, or you don't do anything basically, the player will the player will break the sequence and go back to the idle animation. So it's similar to games like God of War and Assassin's Creed and some other adventure games. Now, partial appending sequencer is where it gets interesting. So, with every keystroke, correct or false, a command is put into a buffer. The scheduler will execute the next command in the queue accordingly. So what that means, you can imagine a game like, for example, Mortal Kombat or Tekken, where you can input four keystrokes and the animation will execute. And if you input three keystrokes, just one after another, real quick, without waiting for the correct pose or without waiting for any specific timing, um, the sequence will also trigger, or the combo will also trigger, but it will not play the last part. So it's like putting the keystrokes inside a buffer, and the scheduler will determine when to play the next animation based on the buffer, based on the command in the buffer. All right. Link begin function does not have any effect, and the link end is the time at which we start linking or transitioning to the next animation. It might look or seem complicated, but it will all come clear and very obvious to you after you start playing with the package itself. It's really easy to use. All you need to know is basically what the link begin and link end functions do, and the general idea of partial sequencing and partial appending and the full sequencer. And that's pretty much it. You can create, I think, any kind of fighting game using these three sequencing types. So yeah. So thank you very much for watching. The next video I'm going to show you a working demo, and we're going to recreate this demo from the scratch. See you in the next video.